The next activity is generating waveforms using the function generator and observing them in the oscilloscope. So first of all, you need to connect the function generator to the oscilloscope using the BNC cable. So what you can do is, so there are different types of cables of with respect to the function generator and the oscilloscope. You can basically use one cable to connect from the function generator to the oscilloscope, but at this moment I don't have such a cable. So what I will do is, I will connect the alligator or the crocodile connectors of the function generator to the respective connectors in the oscilloscope. So first I will connect the black wire. So this is the ground wire, so it is very important to connect it at first. So you can just connect it, and after that you can connect the positive one. So that is the probe end of the oscilloscope to the red crocodile clip on the function generator. So you can just connect it like you normally do, and then this is the basic connection. So now I have established the connection between the function generator and the oscilloscope. After that, you need to power these two on, so it is already on, and then you need to set the function generator to produce a sine wave with frequency 1 kHz and amplitude 2 volts peak to peak. So first of all, in this type of function generator, in this brand, to select the waveform, you need to select the function button and scroll through the list until you reach the sinusoidal waveform. Right, so this is the sinusoidal waveform, but in some other brands you will see a button specifically for the sine wave, for the square wave, for the triangular wave, and etc. So it is not there in this one, but in certain brands it is. Then you need to set the frequency to 1 kHz. So you will select the frequency. I will use the keypad to enter. So I will type 1000 Hz. So this is 1 kHz. Then you need to set the amplitude to 2 volts peak to peak. So I will select the amplitude, then type 2 voltage peak to peak. So now the settings of the function generator are set. Now it is time for you to observe them using the oscilloscope. So I will press the output button of the function generator, and it should technically display the waveform in your oscilloscope. However, in this instant you are not getting a waveform. So you need to basically auto set the x and y axes of the oscilloscope. So for that you need to press the button called auto set. So every oscilloscope will have this button. So once you press that, the oscilloscope will basically display the function that is intended. So sometimes you will not get a really solid waveform. So in that instant, what you need to do is you need to adjust the connections and double check it, and like this you will get a nice waveform. So this is a sinusoidal waveform, but you need to not only observe the waveform as it is, but you need to verify, because here we are using specific measurements, specific values, 1 kHz in frequency and 2 volts in amplitude. So how can you measure that in this oscilloscope? Well, for that you have to use something called a measure function, and again every oscilloscope will have this function. So you will, every digital oscilloscope, so you have a button specifically, so it's called measure. So once you press that button, it will either take you to a brand new menu, or else it will give you some pop-up menus on the side door at the bottom. Again, depending on the brand, it might change, but the functionality remains the same. Firstly, you need to select what channel you want to take the measurement. So since I have connected it to channel 1, so I will select channel 1. In channel 1, now I can select what types of measurements do I want. So here I only need 2, the frequency and peak to peak amplitude. So to select that, you can use the multi-purpose knob in this form of oscilloscope. So I can go here, and frequency to select, you just need to push it, and I will go to the frequency and just push it. So then it will indicate it using a yellow color indicator, and then I need to go to peak to peak voltage. So it is here. So I will go to the peak to peak voltage, and again I will press this button. So these two are selected. Now I need to exit from this menu, again every oscilloscope will have a button called menu off. So that is to remove any menu. So here the button is in this position, so I will select this 2 times to completely get rid of the menu. Now as you can see, you have in the right hand side the frequency measurement and the peak to peak measurement. Now one thing that you should observe is the peak to peak measurement is 21.25 volts. So that can't happen because what we insert was 2 volts. That is because of the scaling. So 2 factors. So first of all, you need to check whether the scaling in your probe is at times 1. So it is at times 1 in this probe. Secondly, there is internal scaling in the oscilloscope as well. So you need to adjust that. To adjust that, you need to click on the button that is in the middle of these 2 knobs in channel 1. When you press that, you will get something called a probe menu. In this probe menu also there is something called probe setup 10x. So this is the reason why we are getting 21 volts. So if I press this, I can select the attenuation and then I can basically reduce to times 1. I can reduce that. In every oscilloscope has this function, and after that you can see my peak to peak voltage stabilized at 2.1 volts. So this is what I need, so I will exit. And lastly, before taking any concrete measurements of your oscilloscope, what you need to do is you need to freeze this signal. There are 2 ways to freeze the signal because this is fluctuating, so you need to have one set of concrete measurements. So you can either press the run stop button. This run stop button is there in almost all the oscilloscopes. This will essentially stop the signal, and again if you press it, it will resume the signal. And also what you can do is, there in certain oscilloscopes you have a button called single. So what this single button does is, when the signal comes to the screen once, it will capture it and it will display it. So as you see, this is a varying signal. This will, this is moving. When you press a single one, it will capture one motion and it will display. So that is the ideal way to actually capture a waveform in the oscilloscope. So I will press a single button, then it stopped, and you can take the readings as 998.4 Hz, again closer to 1 kHz, and then peak to peak amplitude 2.125 volts. So this is how you can produce a waveform using the function generator and observe and verify the result using the oscilloscope and the measure function.